Very good morning, dear students. So we have completed 3 sessions already from 4 sessions, I guess. We have first class on history, art and culture, current affairs. Then we had this economy, reports and indices. And last class we had this international relations. So today we are going to discuss science and technology. Mostly this will be covering all the topics we have discussed in the Sci-Fi science and technology class. We have lot many topics we will be doing in the 2 parts. First part itself is having more than 100 and nearly 120 topics which is given here. Let's get started. Many of these first part will be having these general sciences, topics related to general sciences, then space, astronomy, all these concepts related to this. So in class also what we will be particularly looking at is, we will focus on 2-3 things. One is those topics where there is not much of conceptual importance. We will not be giving too much stress on those. We'll be stressing on topics where that is completely little bit new concepts or new understanding has to be cleared in answering questions related to this. Rest, the factual information you should keep in mind that we will have an overlook. This will be our approach to science and technology. Come to the first topic, physics in a cup of tea. There are few important questions here. One thing is why this tea doesn't seep out of this cooler? What is the major reasons? It is because of this special fluidic material that is formed in these tiny pores of this cooler. So this will act as a layer and which prevents the tea from seeping out of the cooler. Now if you might have seen that it is not just in cooler, it is even in a pot, mud pot, there is micropores within this pot. Come to the topic number 2. Even in this pot, when we put water, not chai, it is also not seeping out of it. What is the reason? The major reason is because the micropores are too small that there will not be any flow across these micropores. Only flow that is happening will be that is by evaporation in this micropore. So when this water in this pot, you can see here, when this water enters these micropores, it will undergo evaporation, and while evaporation the water will be converted into steam. And as you know, there will be requirement of energy for converting this water into steam, and it will absorb this water energy from this water in the pot. That's why you can see the water in earthen pots will become cooler or will become colder over a period of time. Coming to the third topic about viscosity. Viscosity is like a measurement of flow. You can see like resistance to flow is called as viscosity. Water is having a viscosity of 1 centipose, while honey, which is very difficult to flow, it is having a viscosity of 12,200 centipose. You can see here. Why we are discussing this? Because of a recent discovery of a fluid with zero viscosity. It is also called as superfluid, and the fluid is liquid helium. It can, if you keep it in a container, it doesn't form any curvature, rather it tries to seep out of the container because of its non-viscous behavior. Come to topic number 5, 4 fundamental forces of nature. As you can see here, like every force in the nature can be categorized under 4 different categories: gravitation, electromagnetic force, strong nuclear force. Strong nuclear force is the force that keeps this, a force that affects the subatomic particles, like a force within the nucleus of the atom which keeps the electrons, protons together, neutrons and protons together. This force is called strong nuclear force. Similarly, weak nuclear force, this is within the subatomic particles, there will be quarks, there will be fermions, all these kind of things. So the force that holds these subatomic particles together, that is called as weak nuclear force. The strongest of all 4 is the strong like nuclear force, that is the third one. Again, the gravity is the weakest force, but the range of gravity is almost infinite. While the strong nuclear force, the intensity is too high, but as you can see here, its range will be only a few fermions or femtometer. Going ahead, gravitational constant G, you might have familiar with these Newton's law of gravitation, which states that, a second, yeah, so sixth topic, gravitational constant G, it is speaking about. Then the gravitational force is directly proportional to the mass of two objects and inversely proportional to the square of distance between them. And there is a proportionality constant that is being introduced, that is called as G. G is also called as this Henry Cavendish constant, that is the on the basis of whom the scientists who have given an actual value for G. How does an electric battery works? You can go through this lithium ion for so many other reasons, for electric vehicles, developments in these industries. This electric batteries are topics of very much importance. What is cathode? What is anode? What is the electrolyte in electric battery? Every information you should at least go through once. Now, if you look at the lithium reserves throughout the world, you can see in the map here, India is the 5th largest lithium reserves. And where is the world's most lithium located? World's most lithium is located in basically three countries in South America, that is Bolivia, Chile and Argentina. These three countries are otherwise called as lithium triangle also. Do not miss out which are the three countries: Bolivia, Chile and Argentina. Going into topic number 8, battery versus fuel cell. What is the major difference between battery versus a fuel cell? Both these converts chemical energy into this electrical energy, or in car also this electrical energy will be used for different purposes. But what is the major difference is, in battery the energy will be stored in the electrolyte, and this electrolyte chemical reaction will be happening in the electrolyte, releasing the electrical energy. Whereas in fuel cells, the chemical energy present in the two anode and cathode will be utilized for producing this oxidation reaction that is happening between the cathode and anode. Will be utilized, the energy released in this oxidation process will be used as the driving force for this particular energy generation in a fuel cell. So in fuel cell, like in batteries, when this, how many times it can recharge, it depends on the strength of this electrolyte to come back to its original state. Electrolyte is the major component of decay here, whereas in fuel cell you can see how many times you can fill this hydrogen or oxygen. If it is a hydrogen oxygen fuel cell, how many times you can refill these hydrogen and oxygen electrodes. It will continue to process indefinitely. That is the characteristics of this hydrogen oxygen, or there can be methane oxygen or other carbon compounds are also being used as in fuel cells. So a brief comparison of lithium ion battery, its energy intensity and fuel cell is given here. You can go through this. Topic number 9, that is about swing in cricket. Now how swing is happening, there is two basic factors that determines the swing. One is the difference between two sides of the ball, that is one will be shinier side and the other will be a rough side. Now depending on the condition, speed of the ball and this orientation of the ball, all this will make the flow across the ball in certain way. That flow across the ball in the smooth side will be a laminar flow, and flow in this rough side will be a turbulent flow. This will lead to creation of a vacuum, or you can say negative pressure in one end of the bowl. So the bowl moves, force will be generated in the bowl from higher pressure region to lower pressure region, which results in movement of the ball in that direction. That causes the swing bowling. Rust technical principle, reverse swing and normal swing, all these details you can go through this material. I hope you are attending the class with this material in hand. Otherwise, it will be very difficult for you to follow up the topics we are discussing. Topic number 10, that is about SIM cards, electronic SIMs, career profile, all this very factual topic. Not too much going into details of this. Again, topic number 11, that is friction. Friction happens when two surfaces are rubbing against each other. And you can show the highest friction between two surfaces, that is called as static friction. Highest static friction. Then rolling friction, or is one of the lowest friction between two surfaces, while sliding friction is somewhere lesser than static friction, you can see. Now friction has many advantages also. It's not something that is completely bad. It created wear and tear in materials. It created drag when moving of cars, vehicles, airplanes or ships, all these kind of things. On the other hand, we require friction for smooth functioning. We require friction to have grip when we are walking. Lot other applications which is given in the table, you can see. Centrifugal and centripetal force. Centrifugal force is a force that keeps a rotating body. Radiant force that is acting outward direction, whereas centripetal force is a virtual force that is acting along towards this center of this rotating body. Rust, these formula, these characteristics, all these are given here. Piezoelectric material. What is piezoelectric material? That is topic number 13. Scientists previously, like why we are discussing this, because there has been a recent discovery which states that this piezoelectric effect is not just present in solids, it is also present in liquids. So this is a complete new discovery. On the basis of this, there has been reports and news articles. So what exactly is piezoelectric material? You can see here, when we apply stress, when we apply tension or compression on certain materials, there will be change in shape of this material. If this change in shape is leading to production of a electrical charge within this material, then such materials are called as piezoelectric material. This can happen in the other way also. Here what we have said, when we stretch the material or when we compress the material, due to the change in shape of the material, there will be some charge separation within this material. This is called as piezoelectric material. On the reverse side, if you are applying a certain electric charge to the material can undergo a change in shape. This particular feature is called as like the charge formation due to the change in physical form or shape, that is called as piezoelectric effect. Quartz is one of the classic example of piezoelectric effect. Quartz, which is used in watches, which is used in a lot other applications. Mechanism of quartz watches, that is given here. You can go through this material. 15th, Moore's law, that is in use for different reasons. What is Moore's law? An observation that number of transistors on microchip roughly doubles every 2 years, whereas its cost is halved over the same period of time. Basically, it is about like in a square meter, square centimeter area, or whatever is the unit, in that area, how much chips, how much transistors you can occupy. That will decides how much powerful is your phone. You might have seen 4 nanometer processor, 3 nanometer processor. So these nanometer, how much small it is, that much more concentration of transistors you can see in this chipset, and that much more better performing it will be. So that is our standard take. Now, depending every 2 years due to our developments in this semiconductor sector, we can, like in this small area, if 1 year 1000 materials can be, 1000 transistors can be occupied, next year 2 years down the line we will have technology to occupy 2000 within this same set of area. You might have seen these pen drives in 1990s and 2000s, they will be coming in a very huge size. Today you can have a 100 GB pen drive of very small size. So this dynamics has completely changed over a period of time. So this graph is plotted here. Why this is in news is because of recent developments, like how much small you can take this 2 nanometer processors are available right now. So it is very difficult. We have reached somewhere the baseline of physical limits. So it is not always easy to now reduce this size beyond what is capable right now. Secondly, we also have, we are like, all this calculation is based on silicon based transistors, silicon based chipsets, but recently there are research developments that is looking beyond this silicon also, other semiconductors. Recently you might have seen, we are discussing later also, in 2023 the physics Nobel Prize, chemistry Nobel Prize was given to the discovery of quantum dots. So quantum dots are also a artificial semiconductors which can have all the properties of normal semiconductors. So new advents beyond silicon are coming into this arena, and this will greatly change the paradigm and which will change the progression according to Moore's law. Now topic 16, IIT researchers discover rare metal tantalum in Satluj River. So tantalum is not a rare earth metal. Tantalum is a transition metal. It has a lot of applications in nuclear industry, chemical industry, steel production, in bulb production, in immunity applications, all different sectors it has applications. So it is considered as a very strategically important metal. So we have discovered the presence of tantalum in Satluj River. Little bit topics on what are rare earth metals you should understand. According to US Geological Survey, rare earths are a group of 17 minerals that are critical to green energy transition. They are actually abundant in the earth's crust, but rarely in large concentration on their own. Rather, they exist among other elements and often are difficult and expensive to extract. So this is the problem of these rare earth elements. It is not just the lack of abundance is the problem, but it is not available in strong concentration so that we can easily extract them. This is the list of these rare earth elements you can see here. This is the periodic table. Below the periodic table, 17 metals you can find. Topic number 17, feathering. Give me a second. Yeah. What is feathering? So why we are discussing about feathering? A preliminary report by Aircraft Accident Investigation Commission of Nepal on the crash of Yeti Airlines ATR 72500 on January 15 in Pokhara says that the propellers of the plane are found in unusual feathered position. What is this feathered position? Usually when there is an engine failure, single engine or double engine, whatever is this, whenever there is an engine failure that has happened in an aircraft, what is the next thing that a pilot has to do? What is the next thing that pilot has to do is he has to take the flight to the farthest point, reachable point, where he can land it safely. Whether any airport is available near, he should take this flight to the nearest airport. Now flight, even if engine is not working, it will not fall like this. It will be falling only gradually. Now what the pilot should do is, pilot should minimize the drag that is happening in this throughout this engine as well as the body of this airplane. So he will be keeping these wings of the airplane in a particular angle, as well as he will be in the propeller when the engine is not working, still the blades will be there. So if these are the blades, he will be if he keep the blade in this direction and air is coming here, there will be so much of area air hitting the blade and there will be huge drag. This position is called as feathered position. When the engine is working, this is not a problem because from the energy of the engine, the air will be getting so much of energy which will overcome this drag. But when the engine is not working, what the first thing pilot do is change this into a perpendicular position so that even if the air is coming, it is flowing over the wings and not flowing over the blades of the engine and not creating so much of drag. So this particular aircraft failed after an engine failure. Yet the blades of the engine was put in a feathered position, that is high drag position. So due to this, it cannot move beyond a particular limit and it crashed in the mountains and all passengers as well as crew has died in this accident. So people are saying like this was a technical error where these engine blades have been jammed so that it cannot be shifted from this feathered position. So a feathered position is a technical term that was in news regarding this. Now a little bit details on nuclear physics, India's energy installed capacity. You can see here around 53% of India's energy still comes from thermal energy, and out of this, coal is a major supplier, major producer of energy. From renewable, if you look, solar energy is the highest, around 54%. Then we have wind energy, 43%. Biomass, SHP, all these small hydro projects, all these combinedly hold only 10%. Then nuclear is only 2% of current India's energy requirements. You can see like India's 7 operating nuclear power plants like Narora in Uttar Pradesh, Raubata in Rajasthan, Kakrapur in Gujarat, Tarapur in Maharashtra, Kaiga in Karnataka, then Kudankulam in Tamil Nadu and Kalpakkam in Tamil Nadu. All these are like operational nuclear plants across different states of India. As I already told, 6,780 megawatt, that is installed capacity, which constitute nearly 2% of India's energy requirement. Nuclear power station, you can see here. What are different types of nuclear power stations? Like reactor core. Reactor core is the area where this nuclear fuel is there. Control rods and moderators will also be there. Here it is where this nuclear reaction actually happens. Now control rods, what is the control rods? When a nuclear fission reaction is happening, one nucleus will be splitting into one big nucleus will be splitting into 2 smaller nuclei, as well as 3 hot electrons. Hot electrons means high energy, high velocity electrons will also be formed in this process. So the role of control rod is to absorb these excess electrons. If out of these 3 electrons that is being generated, 2 electrons has to be absorbed and only 1 electron should go ahead and hit the next nuclei to sustain this chain reaction. So for that purpose we are using control rods. Mostly it will be made of boron, hafnium, cadmium, etc. Now we have already told that these neutrons will be hot neutrons. That means they will be having high velocity. There should be some mechanism to reduce the velocity of these neutrons so that it is optimum to hit the nuclei. So this purpose is being done by this moderator. Slows down neutrons during this fission to sustain chain reaction. What is used as moderator? That is, sometimes water is used, sometimes heavy water, that is deuterium water is used, or graphite is also used as moderator. Coolant, that will take away the heat from this core to the energy generation phase. Coolant can be water, heavy water, carbon dioxide, helium, mercury, all this can be used as coolant. Pressure vessel encloses the reactor, like whole the reactor will be closed in this pressure vessel. Mostly it will be made of steam alloys. Now steam generator, turbine and generator, containment structure, all this I am not going to discuss too much. Now India's nuclear power projects, if you see, you can see three different stages. From first stage, it will be based on uranium to produce plutonium kind of a reactor. Second stage will be having fast breeder reactors. First stage will be pressurized heavy water reactors. In fast breeder reactors, it utilizes plutonium to produce energy and more fissile material. Third stage focus on thorium to produce uranium 233 for power generation. It is like the stage where thorium will be used. No practical plans have been designed which use thorium. Only research plans or research, you can say, samples are only being produced so far. Yeah. So topic number 20, the 700 megawatt unit are the largest indigenous power plant to be built by Nuclear Power Corporation of India. So this has achieved criticality. So what is criticality? As we have already told that in chain reaction, like one, how we are starting a chain reaction, we will send a neutron to the nucleus of Uranus. Now this neutron will go and hit the nucleus and it will split into two different krypton, baryon, two different elements. In this process, three neutrons will be produced, hot neutrons. Its speed has to be reduced. Two neutrons has to be absorbed. If these two neutrons is not absorbed, it will lead to uncontrolled chain reaction. This is what happens in an atom bomb, uncontrolled chain reaction. If our control rods are overworking, all these three neutrons will be absorbed, and if all three neutrons are absorbed, then this nuclear reaction will come to halt. So a continuous sustainable reaction, two neutrons has to be absorbed, third neutron's velocity has to be reduced so that it can hit the next nucleus. This is the requirement. When this requirement of a nuclear power plant or a power station, the core can sustain a nuclear reaction without going into uncontrolled or coming into standstill. That is called as criticality. So this power plant has achieved at Kakrapur has achieved criticality that it can maintain a sustainable or chain reaction. Can small modular nuclear reactors help India? One thing you have to understand, small modular reactors, these are reactors up to 300 megawatt reactors. What is best of this is it doesn't require too much of water or too much of area to set up. It can be set up near the requirement areas, especially like cities, all these areas it can be installed. These are some of the parts and functioning of small modular reactors. After the class, you can go through this material. Treated water release from Fukushima. What here is happening, this Fukushima, when this nuclear radiation leak has happened, it has kept huge amount of water as in containers, so that this may be ionized water from this nuclear radiation, so it will not releasing this. Now they are saying that there is enough time has passed, after proper filtration they are releasing this water into oceans, but there are concerns related to this. You can see you have to learn some of the major currents near this Japan, because these currents will take this nuclear water not to the coast of Japan but to a lot of other parts of the world. Major currents around Japan include these hot currents like Oyashio current, cold currents like Oyashio current, North Pacific current, California current, North Equatorial Current, Kuroshio Current, Yellow Sea Warm Current, and Tsushima Warm Current. So all these currents in the Pacific Ocean you should have a fair idea about. Now these are nuclear fission and fusion reaction. Not going into detail of this, I'm hope you can easily read this material. It is quite easily available, understandable from the material itself. Energy of 21st century. 24, topic number 24. Strong evidence unusual nitrogen 9 nucleus exists. Scientists say the nuclear nitrogen 9 isotope has unusually high ratio of protons to neutrons. So 9 is usually people have thought that it doesn't exist. Like nitrogen is an element with 7 protons and 7 electrons. Now we have nitrogen 14 isotope with 7 neutrons more. Then there is nitrogen 15 with 8 neutrons. Now 9 neutrons means 9, nitrogen 16 will be 9 neutrons, 7 protons and 7 electrons. This will be having an unusually huge number of neutrons. So people were saying, or like scientifically it was not, in nature also you will not easily find it and it is not easily feasible. But right now scientists are using drip lines which represent these nucleus. 16 has been discovered. So they are looking into this existence of new isotope. What are nucleides? What are different kinds of nucleides like isotopes, isotones, isobars and isomers? What are they? You can look at this table. I'm not discussing too much here. Here you can see an image of a galaxy that is observed through neutrinos. So neutrinos, what are neutrinos? Scientists have produced an image of Milky Way not based on electromagnetic radiation. Like for every observation we are making in the universe, you might have seen this X-ray telescope, you might have seen infrared telescope like James Webb telescope. All these are looking at the universe by looking at different regions of this electromagnetic spectrum. But neutrino observatories, neutrino based images, they are a completely like new approach of observing the universe. Here the universe is observed by not from different aspects of electromagnetic spectrum, but by observing the neutrinos. Neutrinos intensity, neutrino waves are being observed, and based on that we are observing the universe. Neutrinos, if you speak about neutrinos are most surprising particles of the universe, predicted to weigh nothing at all, but they turn out to have small masses and fly through space at nearly speed of light, rarely interacting with matter. These elusive particles play an important role in helping scientists understand some of the fundamental questions in physics. Neutrino properties, they come in 3 flavors: electron neutrino, muon neutrino and tau neutrino. The flavors are not pure states but actually contains a mix of possible masses called as mass states. All other rest features you can read it from here. These are the most distinctive characteristics. Some neutrino observatories you can find here. The first one is the Ice Cube neutrino detector, which is located at South Pole, embedded deep within the Antarctica ice sheet. It detects neutrinos by observing faint light produced when neutrinos interact with ice. Similarly, India also have neutrino observatories. Topic 28, you can see INO or India based neutrino observatory, where it is in Thani district of Tamil Nadu. So it is work is still going on, it is not commissioned. Is neutrino particle its own antiparticle? Antiparticle like proton, we already know the mass of the proton, other characteristics of the proton. The charge of the proton, that is positive. So an antiparticle is a subatomic particle which have all other properties of this proton same, but the charge will not be positive but negative. Except charge, every other mass or other properties will be exactly same. Such a particle is called as antiparticle. Every particle has an antiparticle, identical except opposite charge. An antiparticle has the same mass as its corresponding particle but opposite electric charge and other quantum numbers.